2110 Ballers, and this is our final presentation on the Fall 2018 ME 2110 competition in Prison in Grindelwald. My name is Will Shiner, and my teammates are Chase Anderton, Davis Engelman, and Stockton Delaria. Let's start off with our agenda for today. First, we will go over the project description, then our final design review, our concept alternatives, and evaluation matrix. Finally, we will discuss our results and possible improvements. Let's go with the competition overview. The project competition pitted teams against each other in a 7-foot by 7-foot arena. We were tasked with building a robot that removed a dog bone, aka the Dementors, from our zone, collected gems, the shiny objects, and rejected the squash balls, i.e. Nifflers, and deposited a tennis ball, Grindelwald, in the center of the arena, all within 40 seconds. The points for each activity are shown on the left, while the arena is shown on the right. Let's take a look at some design alternatives that we came up with during our design process to determine the best features for our machine. Our first design alternative is a rolling design. It's actually on wheels. It has a sorting wall that we use to filter the gems and the nifflers, and it deposits the tennis ball using a mousetrap powered arm. Design alternative 2 has the same mousetrap powered arm to deposit the tennis ball, but it is a stationary design and uses a box filter to filter out the gems and the nifflers. It also has a spring-loaded clamp that's used to collect the dog bone, and it has a motor to power the egress. Design alternative 3 was our out-of-the-box design. This was more used as an exercise in creative thinking. It actually uses a cannon to deposit the tennis ball into the center of the zone, and while we recognize that this was impractical, it was an important part of our out-of-the-box thinking skills and definitely got us rolling into Design 4. Design 4 uses the angled drawer slides that you see in our final design. It also uses a similar filter in our final design, and it is also fired by a piston. The differences are in the triggering of the mousetraps and in the collection of the dog bone. We took all of our 4 concepts and put them into an evaluation matrix to determine which features were best for our final machine. Most notably, our first design scored highest in its defense because it was able to roll out into the center of the zone and defend against enemy attempts to deposit squash balls and dog bones. It also scored highest on its tennis ball placement. Similar to Design 2, high score in tennis ball placement, as well as egress. The motor-powered egress is something that we implemented on our final design. Design 3, unfortunately, scored very low on all of the qualifications, and we did not implement any of the features that you've seen here. Design 4 had scored the highest and had a relative total of 0.282, which was the highest by a good margin, and it scored especially high in operating time. The angled drawer slides combined with the piston for firing made it operate very quickly, as well as the time to collect gems because it was able to get out so quickly, and the gem and squash ball points because that filter was so effective. Let's move on to the final design review. Our pre-competition design is pictured above. This is the design that we made using our design alternatives and putting them through our evaluation matrix. Our final design is very similar, but does have some changes, especially in our dog bone collection, whereas this one shows a wall, and in the triggering of the tennis ball arm. So the final competition design is a stationary design with angled drawer sides on each side, fired by a pneumatic actuator. Pneumatic actuator and gravity work together to deploy the machine into the center of the arena and to reach the rotating center. The gems and squash balls are collected and filtered using a 3D printed collector and a laser cut filter. A motor is going to be triggered at 27 seconds to launch the tennis ball into the center and then also to egress. While the machine is egressing, the scoop on the arm will retrieve the dog bone and tuck it neatly back into the machine. Let's look at these components. Deployment is very simple. It's fired by a single pneumatic actuator using the tank and a valve, and it is assisted using gravity to get all the way to the center of the arena. To collect gems, our robot uses a filter and a 3D printed scoop that feeds the filter. The filter is laser cut using 1/4 inch MDF and will allow the gems to drop through it into the home zone, into our zone, and force the squash balls to roll off the ramp into enemy zones. To deploy the tennis ball, the motor will spin and trigger the mousetrap powered arm, which will swing into the center of the zone, into the very, very center, and hit the PVC containment zone for the tennis ball and release it at that point. This is fired at 27 seconds, just on a timer, and the mousetraps allow that tennis ball to be deployed very, very quickly. To egress, the same motor will continue to pull and retract the entire machine along those drawer slides as the motor winds a spindle that has a string on it. To collect the dog bone, during retrieval, the dog bone arm will scoop up the dog bone and drag it back into the machine. Now the dog bone arm is actually tucked up and set during deployment to allow it to clear the dog bone on deployment, and it will be released when it hits the center of the track, allowing it to fall down and then come back on egress and scoop up the dog bone and bring it back into our machine. Let's move on to our results and improvements. Our preliminary results were kind of a mixed bag. We had some successes and some failures. We won the first round of qualifiers. All of our mechanical components worked very well, especially on their own. As a matter of fact, the tennis ball depositing arm on the mousetraps won first place during that week's competition, and the dog bone retrieval and the Jim and Niffler filter worked quite well standalone. Now, some of our failures, namely our mechatronics. Our driver board continued to fail repeatedly. We do believe that one of our mechatronic components had a short in it, which caused a systematic failure of the mechatronic system. Due to that, we did not qualify very well. The same thing happened at the competition. We were not able to achieve any points due to failure of our mechatronics equipment. Some of the modifications we made for the competition from the final design that we came up with using our evaluation matrix really centered around simplicity and then improvements over the previous design. So our simplicity, we removed the solenoid and doubled the motor as the trigger. And then we also modified the trigger just to ease that release and make it a little bit more consistent. And we redesigned the dog bone retrieval system with that arm that swings down when it hits the track. Now the improvements, we 3D printed a gem collector and we re-laser cut the filter to make it a little bit more effective when collecting all of the gems. Now some possible improvements for the future include an IR sensor to integrate into the tennis ball arm thrower. So right now our machine sits with a timed deployment of the tennis ball, but the IR sensor could make that tennis ball deployment a little bit more accurate and a little bit faster. We could also integrate a defense system for squash balls and dog bones. We did not put up any walls to defend against enemy teams, and we certainly could, as well as an offensive system for the dog bone. We could attempt to, rather than retrieve the dog bone, push it into an enemy zone. Also, worth noting, Crest Mechatronics would definitely help improve our machine. Thank you so much. Please direct any questions to the team.